Now we come to one thing which people say is very difficult to understand and this and that. But since there are two methods of looking at the severity of MR which are recommended now, color and area on color, old days. We don't rely on them. We rely on vena contracta and pisa. It takes slightly more time as compared to vena contracta, but not much difference is there. If you calculate vena contracta diligently, then half of the job is already done. Now, what is the concept behind pisa, or what you call as proximal isovelocity surface area? Concept is same what we have read yesterday of the flow and of the continuity equation. It is based upon the continuity equation with some assumptions. We assume that blood approaches the regurgitant orifice in the form of a hemisphere or hemispheric shells. The flow rate is assumed to be same at 2 points in a closed system, and flow is given by this equation. Flow is given by V into A into T, and flow by T is flow rate. We discussed it. So flow rate is equal to velocity into area. Now what we assume is that when this is LV, this is LA, when blood will regurgitate through the regurgitant orifice, okay, we assume that it travels in the form of hemispheric shells. How does a hemispheric shell look like? Somewhat like a parachute. Although parachute is not that spherical. Assume in your mind that you are three-dimensionally you are having something like a parachute, okay, the upper end of the parachute. So what they say is that this is one point, this regurgitant orifice or ERO or effective regurgitant orifice is one point, and this shell at one point here is other point. We assume that flow here will be same as flow here, or for that matter flow rate here will be same as flow rate here. Means velocity into area will be velocity into area. Now this area is in question. We want to find out this area, that is say ERO, effective regurgitant orifice area. This we want to find out. Okay. Velocity, since this is the narrowest point in the system when regurgitation is taking place, if you apply continuous wave Doppler across it, it will give you velocity here, peak velocity, which will correspond to this point. You agree with this or not? When regurgitation taking place, one flow is going to from the LV to the aorta, you know that in systole, and one flow is through the incompetent mitral wall through regurgitant orifice going into the LA. Now this is very narrow area as compared to aortic wall. If it is as large as aortic wall, then patient will probably die. There will not be any forward flow, because this flow starts before the aortic wall opens. We discussed it. When the contraction in the LV starts, when it just crosses the pressure in the LA, the mitral valve closes. And if it is incompetent, then flow will also start at that time only. And aortic wall will open once this contraction has gone from 8 to 80, diastolic pressure of the aortic wall. So throughout this period of isovolumetric contraction, MR will be there. Okay.